Hello? Hello? Yes. Check, check, mic check.
Good afternoon to everyone. Good afternoon to everyone.
Yeah, hello. Good afternoon, everyone. I hope my voice is perfect to everyone. Yeah, okay. So this is Srikanth from Pantech eLearning. I have 2 years experience in EV. Okay. So first of all, a warm welcome to Mr. Coordinator, Mrs. B. Divya Tejashwini, and Principal Dr. R. Naveen, and Convener Dr. K. Narsimhaya Achari. So a great thank to everyone giving this grateful opportunity. So okay. So today we are selecting the topic of EV from Ashoka Womens Engineering College. So we can discuss briefly what is EV. So how to make an EV. Hmm? Yes, and after we can go through the hands-on session. So how we can make it is EV simulation file. So etc. So first of all, we can make a simulation file in MATLAB. So here, what is MATLAB? So MATLAB is a paradigmal, it's a tool, it's a programming, it's a high language programming tool. So here we can make simulation and at the same time we can make mathworks. Okay. So first of all, we can make any product. It's take 3 steps. So the requirement of we can make any product, concept solution, concept verification, and go through the production. So in your MATLAB, the simulation, we can get the solution of the simulation, and that we can verify that concept, and after we can go through the production. So this process or follows the industries. Yes. So this is the one of the MATLAB is one of a high-ended simulation tool. So here the types of some simulation tools: MATLAB Simulink, CAD and ANSYS, MATCAD, etc. Here we are showing the Cleve Muller. He is the first scientist of mathematics, invented scientist. So here you can show. So first of all, firstly we can invent the basic calculator in 1980. After we can go to advanced calculator in 1981. So after we can implement the MathWorks. After we can implement the Simulink. After we can implement the SimScape. So today we are discussing about the topic of EV. So we can make EV simulation file. We need MATLAB R2021A version. So why we need R2021A version means, so in that version, we can completely fulfill the what type of blocks we need for making a EV simulation. So that's why we are using MATLAB R2021A. That's right. So here what is MATLAB or matrix laboratory? MATLAB in the sense of with the matrix laboratory. So it's a multi-paradigm programming language and numerical computing environment tool. So MATLAB allows matrix manipulation, plotting of functions and data, and implementation of algorithms, and creation of user interfaces and interfacing with programs written in other languages. So in we can create EV simulation file in MATLAB where we need two types of contents. So we need two types of contents. That's right. So that one Simulink and Simscape. Here, what is Simulink? What is Simscape? Is a Simulink is a MATLAB based graphical programming language. So here we are in Simulink we develop only modeling graphs. Like so after Simscape we can enable create models of physical systems with Simulink environment in product management with a live type of examples. So yes, 1 minute only. Yes, right. In Simscape we can make real-time components and real type of products, right? So this is basic diagram of Simulink and Simscape. Once check that. So here we are showing the pop-up box, the MATLAB interface. Like so, first we opening in this like that only that interface showing. So here this is called current folder. This is command window. Like this is workspace. So here we can write the programming. So what type of program we can write, we can check in workspace. So currently what type of work we are doing, that showing in current folder, right? So here pop-up box showing up, it's a Simulink box. Once we can open Simulink, we can go model type of Simulink box, right? So here we can select a block model. So this is basic things for MATLAB. It's a basic introduction. So now we are moving into introduction to EV. So what is EV? So EV is an electric vehicle. So what type of content you need? So before developing a product, what type of simulation we can done in MATLAB simulation? So right, we can check that. So first of all, we want to make EV simulation. We can split that parts. So first of all, we can separate the body and battery and vehicle structure. So all structures when we completed, we can assemble the all simulation files, right? So block diagram EV. So here we can give control signal to the motor control and runs to the motor, and that motor we can attach to the vehicle body. So the input of the EV we can take as a battery. So here we can give input to the microcontroller. We can control the motor, right? So vehicle design processor. Here showing so what type of motor we are using and what type of battery. So what type of battery we need and battery capacity, right? So here we are showing the battery consuming the motor types Like here we are showing the DC motor. So here in blue line we are showing that simulating components. The green color showing is the simscape components. And also here the blue color we are showing that electrical components, the green color showing it's mechanical components, right? So here we are showing some forces on EV. So what type of forces occur in the EV? So rolling resistance force, aerodynamic force, hill climbing force, so acceleration force. So you can check that. Here we are making the file, we can take some sample data. So like rider mass, vehicle mass, center of gravity, and drag coefficient, front axial, rear axial, front area, tire parameters. Here some values are showing. Let's check that. So this is called basic vehicle body. So for controlling a battery voltage, we can make some converters. Like this is called chopper. This is DC to DC converter. So what is DC to DC converter? It can convert a unregulated power into regulated power. So here types of converters. Let's check that. Here in UV simulation we are using one non-isolated converter. Why we are using one non-isolated converter? So it is a DC to DC converter, right? We are taking as a DC input. It can purify and filter that DC voltage and gives to and runs our EV model. Okay. So this is called boost converter. We have to check that this boost converter circuit. This is buck converter. So at a time we are making as a hybrid electric vehicle, so we can use as a fuel as a input and battery as a charge, battery as a taking that input. So this is called a hybrid electric vehicle. This is a block diagram series hybrid. So first here we are showing the fuel tank to IC engine. So IC engine to generator to motor. Here one step here we are using fuel and another step we are using battery. So the two things we can connect it to the transmission, right? This is parallel hybrid. So at a time we can run the transmission in parallel way. So here we are showing the block diagram of vehicle architecture. So here we are taking as the input as a battery and power converter, after converter to motor. So motor we can run the transmission, right? So power electronics in your simulation, EV simulation, we are using the power electronics model. What is power electronics? In this application, solid state electronics to control the conversion of electric power. That's why here we are using power electronics. So here we are showing the MATLAB demo. So here we are doing a counter design and DC motor control. How we can done in simulation file, we can check that. So here counter design. In this counter design, here we are taking as a pulse generator and pulse generator to add block and add block to we can run the simulation and how we can get the output. So same the simulation file we can run in counter design. So it's a yeah, sorry guys. So here we are showing the block diagram EV. So for making in EV simulation we need MATLAB. So why we need MATLAB? So in this MATLAB, before we can simulate our file and we can run to that file, and once check that verification of the file, is it okay or not, after we can go to the product. Yes. So here the block diagram of EV. So here we can control the motor and control signal process to the motor control, and that motor control you can go through the motor, after we can connect to the vehicle bed. So here we are input as a taking as a battery, the battery we can connect to the motor controller, right? So in your EV simulation we can use some inverter types. So here showing some types of inverters based upon load type and based upon output waveform type. So basically we are having two types, right? So based on load type we can again divide it into single phase, and single phase we can again classified into half bridge, and that half bridge, and another one is full bridge. So in based on load type we can again classify it into three phase inverter, that is 120 degree mode, 180 degree mode, and based on output waveform type, that is square wave and modified sine wave, pure sine wave. So we can discuss it one by one. So working principle of 180-degree mode and 120-degree mode inverter. So here we are using conduction mode, right? In 180-degree mode we are using 3 switches will be on at a mode time and remaining switch will be off. In 120-degree mode 2 switches will be on at a mode time and remaining switches will be off. So this is called a single phase inverter. So here we are using is a pulse width modulation technique, and we can control the voltage like below 100 volts. So this is called a single phase inverter, right? So this is basic demo of in MATLAB simulation inverter design. So this is single phase 120-degree mode inverter. So here we are using as a input as a DC volts, and we can use switches. After we can convert as a inverter DC into AC voltage. So how we can work that 3-phase inverter? We can explain that. Wait. So here we are showing the block diagram of 3-phase inverter. So here we are using 6 switches. We can give the pulse to the switches, and that pulse we can run to the motor. This is called 3-phase inverter. Here we are using as a DC input, and we can use 6 switches, and we can give pulse by using pulse generator by using PWM technique. After we can give the output as a D grid, right? So that a DC we can convert into pure AC waveform. Yeah, okay. So this is here we are showing the ideal 3-phase voltage waveforms, right? So here first line, here you can complete in 120-degree mode. So inverter working principle. So we need any inverter for conditional working, we need a switching table. So based upon switching table, that inverter also working, we can give that switching pulse to the pulse generator. So like that only, that pulse generator we can work by using PWM technique. PWM in the sense of pulse width modulation technique. So here using switching conditions. So here we are in 3-phase inverter, we are using 6 switches, right? So each switch mode, in mode and conditions, how many switches are turned on in mode 1, and how many switches are turned off in mode 2. So here we are showing the switching table. So in mode 1, at a time we can turn on 3 switches, right? So first input we are taking as a DC, that a DC can, based upon the switching table, we can give pulse to the each switch, and that each switch pulse we can go to the first. Here 3 switches turned on, right? So first pulse going to first switch, and after we can that pulse going to passes through. So remaining switches turned off, right? Passes through the second switch. That second switch again passing to the motor. That motor we can turn to the pulse, and it transfer to the third switch, right? So here like that only in mode 1 that switch will work. Here we are using mode 2 based upon that switching table. How many switches turned on? In blue line we are showing. So at a time 3 switches turned on, at a time 3 switches turned off. So this is mode 4. So here 3 switches turned on and 3 switches turned off. Like that only we can make as inverter circuit. So we can control the EV So we can control the EV motor. We need a AC voltage. Sometimes that's why we are using as an inverter. So that inverter voltage we can control the motor. That's why here in our EV simulation we are using inverter circuit. So this is mode 5, this is mode 6. So like that only here blue line showing that switches turned and turned off conditions. Like that only that motor we can control. Here showing parallel and series condition of the states and switches of the mode operation in graphical way, in calculation way. Here we can check that, we can move forward. So here types of applications of inverter. So we can control motor control in EV applications and home applications and industry motor control. So that's why we can use in inverter, right? So this is 5 level 8 switches inverter type circuit. This is model based. Once check this one. So we can move. We need to download, we need to demo of the 5 level 8 switches hardware making. Here we can follow the link, you can search it in YouTube, you can watch the video. So we can go through the EV design. So intro to the electric motor of EV applications. So we can move forward. So for EV design we need motor basics, types and motor parameters. So we can make in MATLAB demo. So why we need MATLAB already discussing. So we can each simulation we can make in MATLAB. So we can check that simulation is working or not perfectly. So after we can go through the production. So here some types of motors of EV applications. So what is a motor? So motor is a electrical energy is converted into mechanical energy. Okay, we can give as a input as a electrical energy and we can run the motor and we can control the motor. That motor we can connect to the tires, chassis, body, right? So we can control that mechanical energy. So here we are showing PSM model BLDC motor, right? This is called BLDC motor. So this is the one type of permanent magnet synchronous motor. In our demo we are using different one. We can go through the forward, we can engage the entire session, that time we can get some idea of that. Okay, so here what type of motor requirements and what type of specification we need we can control in our EV model. So here we are mentioned, so we need a high efficiency motor and high instant power and fast torque response and high power density. At the same time we can check the cost and we can find that low cost motors and high acceleration motors and robustness motors. So we can select that type of motors. So here the types of motors, right? So we have the electric motor two types, commutator and commutatorless motors. So here in commutator motors again classified into self-excited motor and separator excited motors. So that motors we can connect it into series or shunt in field excited motors and PM excited motors. So here we can classify it into commutatorless motors. That motors are called asynchronous motors, synchronous motors, and PM brushless motors, and switched reluctance motors, and PM hybrid motor. So based upon our requirement, our EV requirement, we can select that motor and we can control that motor. We can give input as a motor, we can check that motor, and we can in our simulation we can control the motor, right? So here the demo of Jita BLDC motor, right? This is the simulation of Jita BLDC motor. So here in our simulation we are using BLDC motor. So we can control by using Jita converter. This is the model simulation of Jita BLDC motor. So you need to make this hardware. You can follow the link and you can watch the video. You can start your work. So here we are showing the demo pics of commutator motors. Once check that commutator motors, right? So here we are showing commutator-less motors. So what is the commutator-less and commutator motors, right? Here we are using commutator-less motors. We can reduce the brushes. So in this commutator-less motors, that lifespan also increases and it's working on more time. So that's why we are using mostly in commutator-less motors. So here we are showing the basics of some motor basic parameters, right? So what type of motor power we need, so what torque produce the motor, so what type of motor speed. So here we are showing, so what type of motor power we need. An electric motor is an electric machine that convert electricity into mechanical energy. Here that called is motor power. So what is called motor torque? The driving force of an electric motor is called torque. So what is the driving force means how much speed, that rotational speed is giving to the shaft, and per minute is called as torque, right? And what type of motor speed we need it. So here we are measuring the speed of motor in revolution per minute. So here we are taking the types of motors in RPM. So we need more power, more consumption, like our vehicle need to more power. So that time we can increase the motor RPM speed and we can use that motors. So this is another type of motor. This is an induction motor, right? So in our EV simulation we can use induction motor also. So we can change our basic below parameters. We can change into our inputs and outputs. So we can select different type of motors. We can make a different type of circuits and different type of inverters and converters, right? What type of input we are giving, what type of output we are taking. So they are based upon we are taking time, that is changed. So we can control the DC motor speed by using MATLAB Simulink. Here we are showing the demo. So this is called DC motor. So here we are using the blocks of DC motors, right? So that time we can control the DC motor speed. So in our EV we need a charge. So we can give charge to the motor. So that time what type of motors we are selecting and what type of circuits we are using. So based upon that motor's terms and conditions we can give charge to the battery, right? So here we are developing single drive system, means so we can connect the motor in rear wheel axle, that is called a single drive system. So that is called a single drive system, right? So dual drive means we can connect to the two types of motors in front wheel and rear wheel axial. We can connect to that motors is called dual drive motor. At a time we can drive the all wheels is called all wheel drive system. So here some applications of EV motors. So here this is hub motors. These types of all hub motors we can use the basic EV vehicles like EV scooter or EV cycle. That motors are called hub motors. So here we are showing the purpose of controller, why we need controller and how we can use controller. Here mentioning that we can starting by using the controller we can give input and we can control the circuit, right? So what type of input we are giving, what type of output we are taking, based upon that controller we can control the power. So after when we need to stop the power, so that time we can controller we can stop the input. So and also we can control the speed of motor and safety operator, protection from damage. So that's why we are using controller. Controller is a brain of our EV simulation, right? So in hardware implementation also we are using different types of controllers based upon our requirement, based upon our type of EV, like EV electric vehicle. So that time we can change our controller. So here we are showing the top 10 best electric motor vehicles in the world. So Harley Davidson Livewire, so Giro SR and Energy Ego, so Bruton Y9 and Jammer J1. So here some types of best electric motor vehicles. Here we check that. So here we are control the DC motor in EV applications. How we can control, we can check that. So here we can control DC motor in EV applications, we can check that one. So this is the experimental 2 wheels EV model with the tire formula. So our requirement, we can use it 4 wheels and 2 wheels. So based upon our requirement, we can use it. We need EV scooter, means we can use a 2 wheels model. We need a car type of EV model, EV simulation, we can use a 4 wheels. So by going hands-on session, that time we can get some deep understanding about the simulation. So right, we can move forward. Before we are making an EV simulations, what type of contents we provide, so what type of input we are taking, what type of introduction, so how it is working, and types and advantages, and the demo of EV simulation. So everything we can provide. So here some types of DC motors, check it out. DC motors, so this is called a driver board. Is why we are using driver board, means it is switching and amplifies the input power and gives the purifier output. So that's why we are using driver board. So this is one DSP IC controller. So based upon our requirement, we can use different types of controllers. This is one type of DSP IC controller. Here we can shake the pic. So this is one FPGA board. So high-end resolution, we can use the FPGA board. So this is one type of TMS320F281 development kit. Here we can check that. So in our motors, in our EV applications, basically we are using as a BLDC motor. What is BLDC motor? Means brushless DC motor. Here we are mentioning some specifications. So power as a 60 watts and voltage we need a 24 volts. It's mostly the speed of the BLDC motor is 3000 RPM. So this is the basic hardware kit of a BLDC motor. We can control that motor. So why we need to show this everything, means so this all contents, the combination, we can assemble the all contents of the before hardware and simulation. That time we can get a product of hardware. So that's why we are showing. So in our EV applications, we are taking as a battery as input. So battery of EV applications we are measuring, we are discussing about that. So what is a battery? It's a device can convert into chemical energy into electrical energy. So what type of batteries are there? So here battery types. So we are having two types of batteries, right? Primary battery and secondary battery. What is primary battery? What is secondary battery? A primary battery is a non-rechargeable battery. Once we can use and we can throw into dustbin. We cannot reuse and re-again the battery. And secondary battery is a rechargeable battery. So in secondary battery we can recharge again and again. We can use that secondary battery. So how we can connect to the battery of EV and how the battery working, here we are showing. So in our battery we are having cathode and anode and electrolyte. So that cathode and the anode we can transfer to and we can connect to the load. So here we are showing the connection of battery. So this is a battery equivalent circuit, right? Here this circuit we can develop into MATLAB. So in our EV simulation, the battery charge and discharge the automation by using Simulink. So when we need charge, when we can use the EV vehicle, that time the battery can discharge. So that's why here mentioning charge and discharging process, and we can manage the battery, and the battery is completely gone, that time we can change into battery. So this is the bidirectional model Simulink of a battery. So bidirectional means in the sense of we can give input and we can store the battery, and when we need the battery power, that time we can use the again battery for input as a taking from battery. So that is called bidirectional battery model. So types of EV battery, we are having the 4 types of EV battery. So lithium ion battery, lithium phosphate battery, nickel metal hybrid batteries, lead acid batteries, right? So here we are showing the pic of, so inside batteries what contents are needed in this battery and what types of components inside measuring in this battery. So here we are showing, so electrolyte, phosphorus separator and electrolyte, and lithium ion battery, in the sense we are using lithium ion. So here we are showing the battery contents. So the battery configuration, what is the battery configuration means? So here the 3 types of configuration of battery we can assembling into series and parallel conditions, right? So what is the series and parallel condition, we can check that. So here we are showing the series configuration, right? In this series configuration we can take as a battery cell, that each cell we can connect into series configuration. So that series configuration we can increase the power, like input voltage, that input we can connect into the load. So cells we can assemble and we can connect our series or parallel. So what type of you need, so your requirement purpose we can connect that, and we can connect to the load. So this is parallel configuration. So in this parallel configuration we are using cells and connecting to the circuit as a parallel, and we can get, so what type of input we are taking, finally we are getting load taking as that input only. So that time, so one cell completion, after one cell, here we are consuming the load from the battery. So this is parallel series combination. So the combination of both is called a series and parallel combination. So at a time series we can use and parallel we can connect to the load. So based upon your requirement we can connect the series connection or parallel connection. So here the vehicle cover 100 kilometers in 1 hour by using the battery rating of 72 volts in 166.67 amperes. So here some basic demo of the battery in EV. So in real time components also, in real type of industries also, same type of batteries we are using. So same battery in our hill climbing and angular forces are changed. That time the battery consuming quickly and reducing the distance also. So based upon the vehicle going through process, that time we can change the battery. Here we are showing that battery assembly of EV, right? So we can connect the each cell, we can assembly, and we can connect the more power, and we can that battery we can connect to the our EV model. This is some approximate prices of batteries, right? We can check that battery prices, right? So battery charger design, you can show the demo of battery show. So here we are using as a DC voltage source. We can convert the bidirectional DC to DC converter. That converter to we can connect to the load. So here we are using bidirectional DC to DC converter. When we need as a power of a load, we can take that time. So we can connect to the battery. So DC voltage source we can connect to the battery, and we can charge the battery. That time again when we need, so we are not taking as a charger like DC voltage, we are not giving to that time. We can take a battery from input, right? So this is called bidirectional DC to DC converter. So here again showing the battery equivalent circuit, right? So this is cell arrangement. Once shake that, so how we can connect to negative to negative cell, positive to positive cell. So here we are showing. Once check this picture. So in our EV simulation we can manage the battery system. So what type of SOC? SOC in the sense of state of charge, SOH in the sense of state of health, and cell power, and we can measure the up to date and on time. We can measure that values also. So here we are showing the battery management system. So battery management system in the sense of BMS. What is BMS? So electronic circuit. So here the battery can connect to the electronic circuit. That electronic circuit we can measure the battery life and battery protection and ensure the battery parameters, right? So in our cell assembling of cell, we can taking as a big battery. So that battery we can connect to the our EV simulation or our EV real time component or our EV vehicle, right? So this is battery pack. So main functions and what type of problems we are facing in BMS. So how we can rectify the BMS. So like that we can mention that. So here we are facing main problems of battery voltage and temperature current, right? So here we are showing some additional BMS applications, right? Here voltage equal to, so BMS, the functions of BMS here we are measuring. So it can rectify the voltage problems and state of charge problem and state of health, and also state of power we can measure. Up to time we can measure that values, and when the battery is fully discharged, at that time we can charge the battery before it can intimation to you. So that time we can charge the battery. So that's why mainly we are using BMS, right? So in our BMS we can measure the SOC estimation, right? So mainly the BMS we can show the battery life, and it will be connected to the dashboard of the battery, our vehicle. So it can measure the values and it can show the health. So by using BMS we can measure the SOC and SOH, and finally we can protect the battery. So that's why we are using BMS. So here some types of batteries, we are already checking that. So now we can move the vehicle constructions. So first of all, what type of construction we need, so how we can measure that.
కంప్లీట్ అయ్యేటప్పుడు ఓపీఎస్లో యూట్యూబ్లో రెండిట్లో ఎండ్ స్ట్రీమ్ స్టాప్ స్ట్రీమ్ కొట్టేసి
And the architecture, so I will show that one. So this is our model. So this is the demo of our model EV simulation for 4 wheels. So here we are taking is input as a battery, and we can use as a PWM average converter. That converter we can use to motor, that motor to we can connect to gear system, that gear system we can connect to the vehicle body. So each step and each connection we can make, and we can assemble that components. So now we are showing the hands-on session through using MATLAB. I will show the demo and the running of the simulation. So everything, wait. So we can go through the hands-on session. So now I am opening the MATLAB, right? So this is the interface of MATLAB. So why we need a MATLAB means, in the sense we can simulate the circuit and we can check the circuit is working properly or working not, what type of inputs are taking, what type of output we are measuring. So that's why we are, before we are mentioning in our MATLAB we can simulate that circuit. After we can give the production to the industries. So here we are showing our EV simulation model, right? So here we are giving as the input as a battery pack system, and that battery pack we can convert to the PWM converter, in the sense by using the PWM technique. So we need any converter to like a DC to DC converter. So that battery power we can purify and rectify the PWM technique, PWM average converter by using. So after that battery input as given to the gear system, so here the battery is connecting to the motor. So here using motor inputs, and right, so the motor is connecting to the gear system. We can connect to the automatic gears, that gears based upon your requirement you are giving to acceleration by using signal. So this signal builder giving to automatically changing into gears. So that gear system we can connect to the brake. So when we need to stop the vehicle, that time we can use the brake. That brake, this whole concept we can connect to the body. In body what type of inputs are measured, I will show you. So each component, each block I will show you. So this is called vehicle body. So here we are using 4-wheel EV simulation model, right? So this is called 4 wheels type of, so magical formula type of tires. So the tires we can connect to the vehicle body. That whole body we can measure as a vehicle body. So that vehicle body is again connected to the braking system. The braking system is connected to the gear system connecting through the motor connecting to the averaged converter. It's a PWM voltage regulator, voltage and current controller. This one type of controller. So that controller is connected to the input battery. So each cell we can connect by using circuit, that is circuit we can assembling as a battery, and that each cell we can assembling as a battery. So now we can run the simulation, and what type of inputs and what type of outputs we are getting, we can check the scope block. Still it's running, wait. So here we are using a running button, this is called stop time. So in which time of seconds, in how many seconds we can measure, we can stop the vehicle. So here finally we are measuring the speed and distance, okay, right, in how many kilometers are going through and how much speed it can gaining the speed and how much distance. So here we are measuring distance in the sense of meters and speed in kilometer per hour. So here we are going through 80 kilometer per hour, 81.25. So by how much time? So here we are going to 34 seconds, right? So in 34 seconds, by going through 81 kilometer per hour speed, is measuring is measuring the distance in 144 meters, right? So the waveforms also we can measure the waveforms. So I will show the waveforms, right? So here we are showing the vehicle speed. So first in first gear we can go through this slowly. So after gaining the speed, we can go through, we can increase the speed. After we can go 80 kilometers per hour. So how much distance it's cover means, so here we are covering the distance of 144, right? Here we can measure the distance, how much distance it will be covered to the distance of the vehicle. So it's right. So how much time it taking to cover the distance, here showing the downside time. So 30, finally we are taking as a 34 seconds time, right? We can change our parameters, we can change our vehicle inputs like outputs, right? So based upon our requirement we can make our simulation file, okay? So this is our vehicle architecture. Once again I will tell you, this is battery. You can make battery circuit, and each cell circuit we can come assembling it as a battery pack. That battery pack is connected to the PWM average converter by using in the sense of current and voltage converter, and measuring that converter is connected to the motor. So motor we can run, here we can run the motor. So this motor is connected to the gearing system. So here we are giving to the signals. So the gearing system is automatically changing into gears. So that gearing system is connected to the brake. That brake and whole part is connected to the vehicle body, and we can check that simulation. So after we are making the simulation file, so same thing, same input, same blocks we can measure. So we can go through the production. So right, so some industries are following these steps. And MATLAB, why using the MATLAB is, in the sense of is a free source software we can download from free free source, right? We can use the freely, so that's why we are taking as a some industries also choosing a MATLAB, right? So it is now EV is a high demanded concept, right? So I think you can get some idea about EV, so how we can measure EV, so what type of contents we are using. So right, so you guys, we having any doubt, just ping me, and we are giving our contacts. You having any doubt, just contact Pantech eLearning. So right, so once again a great thanks to giving this opportunity our coordinator B Divya Tejashni ma'am and principal R Naveen and converter Narsimhaya Achari. Thank you everyone, thank you each and everyone. Yeah, okay, bye bye. Good.